Okay, geometry, this is the second half of section 9.6. We did the first side or the first page in the last video, and now we're going to finish this back side here. So just a couple of examples, but I'm going to kind of go through and highlight some points here. Basically, three things are happening when we're dealing with secants and tangents and how they are intersecting with each other. Okay, so let me break this down for you this way. Okay, in this top part here, we were taking the average of the two arcs. So we were taking 140 plus 160, dividing by 2, and that gave us 150 in the middle here, and that will tell us what this angle is, okay? Now notice here that those two lines that are intersecting each other, both of those are secant lines. So this is a secant line, this is a secant line, but they are intersect inside the circle, okay? So those two lines are intersecting inside of the circle. So what I'm going to do is I'm going to add the arcs and divide by 2. Okay, I add those two arc measures and I divide by 2. This is going to be kind of your cheat sheet over here off to the side that tells you what to do. So if I'm intersecting inside the circle and I'm trying to find that angle there, I'm adding the two arcs and I'm dividing by 2. Okay, now this one here, we had a secant line and a tangent line that were intersecting with each other. Okay, and notice where they are intersecting. They're intersecting right here at part A, or at point A, which is on the outside of the circle. So here's your little cheat sheet over here. If they intersect on the edge of the circle, you just divide by 2. Okay, that's kind of how that rule works. Okay, so what I did here was I said if this is 160 and I'm trying to find this arc here, I just divide that by 2 and that gives me 180 to find the measure of angle 1. Here, if I had this as 200 degrees, I'm just dividing by 2 to get that angle 2 as 100 degrees. So if they're intersecting on the edge of the circle, you're just dividing that arc by 2. You're not adding them together and dividing by 2 like you did up here. Okay. Now over here on the back side, okay, this is the last concept. What I have going on here is I have this line here and this line here, okay? And this is a secant line because he's touching at 2 points, and this is a secant line because it's touching at 2 points. And what's happening is where they are intersecting is point here at A, okay, which is on the outside of the circle, okay? It's the point where they're touching is on the outside of the circle. This one I have a secant line here because it's touching at 2 points. This is a secant line. This bottom one here is only touching at 1 point, so that's a tangent line. But again, both of those points are touching on the outside of the circle, okay? Here I have two tangent lines. I have a tangent line here and a tangent line here because they're only touching the circle at 1 point. So this one's a tangent line and a tangent line, but notice they are both still connecting on the outside of the circle. So if lines intersect on outside of the circle, okay, here's what you do. We're looking at these two arcs here, so arc DE and arc BC, and arc DC and arc BC, those two arcs there, and this arc here, and this arc here, okay? What you're going to do is to find the measure of this angle. That's what we're trying to find every time, the measure of this angle right here. What you're going to do is we're going to take the larger arc, this arc right here, and subtract this one, and divide by 2. This one minus this one divided by 2. This large one minus the small one divided by 2. And that will give you the measure of this little inside place where they connect with each other. Okay, so I'm going to say subtract the arcs and divide by 2. Okay, so that's your little cheat sheet on the outside here. Okay, so it's always dividing by 2 of some sort. Okay. On the front side here, we were adding the two arcs together because they intersected in the inside, adding the two arcs together and dividing by 2 to get this angle. Okay. Here they were intersecting on the circle, just divided by 2. Okay. Here they were intersecting on the outside of the circle, subtract, divide by 2. Okay. So that's kind of what they're talking about here in this key concept. This is like where they're putting it all together. So if they intersect on the circle, you are just dividing by 2. If they intersect inside of the circle, like this one, you're going to add and divide by 2. If they're intersecting on the outside of the circle, like these dots are where those two lines are touching, you're going to subtract and divide by 2. So that's the rule. You don't really have to get all muddled with, is that a secant line? Is that a tangent line? What is it? If they're touching, if they're two lines that are being looked at, if they're intersecting the inside, outside, on the circle, it's add, subtract, or just divide by 2. Okay. All right. So find each measure. They want us here to find the measure of angle L. Okay. Now this guy is a tangent line. And this guy is also a tangent line because he's touching just one point, okay? And they tell me that this arc right here, that little middle piece, is 102, and that's all they tell me. That's all they tell me. And I'm expected to find this little angle right there, okay? Now, I need to know what both of the arcs are. I need to know what this thing going around the outside here is. If this is 102, this, though, will be the rest of that, right? 360 is all the way around the circle, but if this guy's 102, then I can figure out what that top part is, okay? So I'm going to take 360, and I'm going to subtract 102, and if you want to try to do this in your head, you sure can. 258 is that outside circle, or that outside degree, that orange piece, all the way around, okay? So if I'm trying to find angle L, since he's connecting on the outside of the circle, I subtract and divide by 2. So 258 minus 102, and I divide that by 2, okay? 258 minus 102 is going to be 256 divided by 2, okay? 256 divided by 2 is going to be 128 degrees, so that's what the measure of angle L will be, okay? So I subtract those two divided by 2. Sometimes you're going to have to search for some of the other angles, though. They won't just necessarily always give them to you, okay? All right, now, find the measure of arc CD. Okay, so this is the confusing one, okay, because normally we're trying to solve for A, but they're already giving us that A is 56 degrees, and then they give us this inside arc here is 95, okay? Now, we can't just subtract from 360 because there's this other piece out here that we're not even using, right? Okay, and we don't know how big that is. Otherwise, we could just figure out what that is by subtracting from 360, but that's not going to work, okay? So let's just call this guy on the outside here X. This CD that we're trying to find, let's call him X. Okay, and so to find him, or to set up an equation for this scenario here, what we would do is we would take X, the bigger arc, we would subtract 95 and divide that by 2, and that would give us 56 degrees. Right, that would give us that angle in there. So I've just set up my equation here, and I'm just going to work it backwards, kind of like we did on an example on the front side here. Okay, I'm going to multiply by 2 to get that 2 to go away. So X minus 95 is going to be 56 times 2, which I think is 112 degrees. Okay, now I'm going to add the 95 over, and X is going to be 112 plus 95 is 207. 207 degrees, I think, is what that is. Okay, and we can check our answer by 207 minus 95 divided by 2 should be 56. Okay, that's the way that should work, because they're intersecting on the outside of the circle. So we subtract the two arcs. The bigger one minus the smaller one divided by 2 will give us the other piece. Okay. All right, now the diagram shows the path of a light ray as it hits a droplet of water. The ray is bent or refracted at points A, B, and C. Okay, so the light is refracted this direction. So as the light ray enters, it's like bent and it touches down here at B. As the light ray enters this way, it's bent right here and it touches at B. Okay, so what they say here is they have the measure of arc AC. So the distance basically between the light is 128 degrees. So this arc right here is 128, okay, from there to there, all right? And then they say the measure of XBY, which is this arc right here, is 84 degrees, okay? They want to know what angle D is, okay? So let's look at what we have going on here. If I take that light and I pretend as though it wasn't bent and make it a straight line all the way through, and this bottom light ray, and pretend that it wasn't bent and going all the way through, they're going to intersect at point D, which is on the outside of the circle. Okay, which means outside, I'm going to subtract. Okay, so what two things do I subtract? I take the 128, which is the arc in between the two lines, 84, which is the other arc that's between the two lines. Okay, I subtract those and I divide by 2. Okay, 128 minus 84 divided by 2. 128 divided or minus 84 is going to be 44 divided by 2, and that is 22 degrees. Try to do as much of this as you can in your heads. So this guy is going to be a 22-degree angle. All right. So that's just kind of how this breaks down. You're either just dividing by 2, adding divided by 2, subtracting divided by 2, and it just all depends on where they're intersecting. On the edge of the circle, that's on the outside of the circle, is to just divide by 2. Inside the circle is add divide by 2. On the outside of the circle is subtract and divide by 2. Okay? All right, there we go.